Good morning, students. Welcome to the 7th session of Sequences and Series. In today's class, we shall continue with problems on GP. Problem number 8 states that find the sum to indicated number of terms in each of the following GPs. So we have to find out the sum to the indicated number of terms in each of these questions. Okay, there are totally 4 questions here. Look at the first question, sub question A. The given GP is 0.15, 0.015, 0.0015, so on. We have to find out the sum to the first 20 terms of that particular GP. So we will start the solution like this. Solution. First we will write the given GP. This is sub question A. The given GP is 0.15, 0.015, 0.0015, so on. So the first 3 terms of this GP are given. What is the first term? So here first term A is 0.15. First term A is 0.15. Common ratio small r. We will perform the ratio between consecutive terms. Second term divided by the first term. What do we get? 0.015 whole divided by 0.15. Okay, 0.015. How can I write this in terms of fractions? How can I write this in fraction form? I can write this as 15 by 1000, right? 15 by 1000 is 0.015 divided by, how can I write 0.15 in fractions? I can write that as 15 by 100. So 0.015, I have written it in fractions, that is 15 by 1000. 0.15 in fraction form is 15 by 100. So how do you simplify this? 15 cancels with 15, then 100 cancels with 100, and I am left with what? 1 by 10. What is 1 by 10 in decimal form? That I can write it as 0.1. So small letter r, the common ratio is nothing but 0.1. Now the question is asking us to find out the sum of first 20 terms. That is, we need to find S20. So we need to find S20, right? So we have to find out value of S20. We can use the formula of Sn. So what is Sn for a GP? It is A into r power n minus 1 divided by r minus 1, where A is first term, r is common ratio. So using that formula, what will S20 become? So we have S20 using Sn formula of GP. A, what is value of A? 0.15. A into r power 20, right? R value is 0.1. So that is 0.1 power 20 minus 1 whole divided by r minus 1. Value of r is 0.1. So that is 0.1 minus 1. So we have used the formula of Sn and we have calculated the value of S20. We can further simplify this RHS. So how can I do that? 0.15 I'll write as it is. Then we have 0.1 power 20 minus 1 divided by 0.1 minus 1. So what is the value of 0.1 minus 1? It is nothing but minus 0.9, right? 0.1 minus 1, we get minus 0.9. Then I can write 0.15 as in fraction form, that is 15 by 100. So into 0.1 whole power 20 minus 1. This as it is I have written, whole divided by minus 0.9 in fraction form. It is nothing but minus 9 by 10. So on further simplifying this, okay, so what do we get? 110 cancels with 110, 3 3s are 9, 3 5s are 15. Then I can further simplify this. 5 1s are 5, 2s are 10. So I have 1 by 2 in the numerator and minus 3 in the denominator. On further simplifying this, so what do we get? 1 by 2 divided by minus 3 is nothing but minus 1 by 6. So I have minus 1 by 6 into 0.1 whole power 20 minus 1 as it is. If I multiply this minus sign inside the brackets, what do we get? We get 1 by 6 into 1 minus 0.1 whole power 20. So this is the simplified form of S20. So what is the value? 1 by 6 into 1 minus 0.1 whole power 20. Moving on to sub-question B. We move on to sub-question B here. What is the given GP here? The given GP is 1, comma minus a, comma a square, comma a cube, comma so on. So the given GP, this is sub-question B. The given GP is 1, comma minus a, comma a square, comma minus a cube, comma so on. Okay. Now look at this GP. What is first term of this GP? It is 1. So small a value is 1. Then common ratio small r. Second term divided by first term, that is minus a by 1, that is nothing but minus a. Okay, so the first term of this GP is 1 and the common ratio small r is nothing but minus a. Now we need to find what? Sum to n terms of this GP. 1, comma minus a, comma a square, comma so on. Sum to n terms of this GP. So in other words, we need to find Sn of this GP. Okay, same method, same thing we are doing. What is Sn of a GP? Sn formula of a GP is nothing but a into r power n minus 1 by r minus 1. So we have Sn equals a. What is the first term a here? It is 1 into r. R value is minus a. R power n is minus a power n. R power n minus 1 by r minus 1. Value of r is minus a. That is minus a minus 1 we have. What have I done? I have just substituted the values of a and r. That is the first term and the common ratio of this GP in the Sn formula. So we have got this. On further simplifying this, what do we have? Minus a whole power n minus 1 whole divided by, I can take minus common from the denominator. What do we get? I can write this as minus of a plus 1. When I take minus common from the denominator, we have minus of a plus 1. Multiplying this minus sign in the numerator, what happens to the numerator? So what do we have? Minus 1 into minus becomes plus 1. Minus 1 into minus a whole power n. I can write it as minus of minus a whole power n whole divided by, the denominator we are left with 1 plus a or a plus 1. So sum of n terms of the GP 1 comma minus a comma a square comma minus a cube comma so on is 1 minus of minus a whole power n whole divided by 1 plus a. So sub-questions C and D, you try these as homework. Okay, same method. First we have to consider the given GP, write the first term of the GP, then you find out the common ratio, then for this you have to find out again sum to n terms of this GP. Again for the last one, same method, find the sum to n terms. Moving on to the next problem. The next problem states that sum of first three terms of a GP is 39 by 10 and their product is 1. Find common ratio and the terms of the GP. Okay, now we will for this problem we will take the terms of the GP as a by r, a and a into r. Okay, so we'll start the solutions like this. Solution: let the three terms of the GP be a by r comma a r. Okay, so we have taken the terms of the GP as a by r comma a into r. So the first term is a by r, second term we have taken it to be a, and the last term, the third term, we have taken it to be a into r. Okay, now in light of this definition, you just look at the problem. What is given there? Sum of first three terms is 39 by 10. So sum of these three terms we have to write it as 39 by 10. So I'll write by data we have a by r plus a ar equals 39 by 10. So this follows from what is given in the problem. Sum is 39 by 10. We have taken the three terms to be a by r, a and ar. Hence we get what? A by r plus ar equals 39 by 10. Okay, on taking a common from this, what do we get? I can write this as a into 1 by r plus 1 plus r equals 39 by 10. We will take this as equation number 1. So we simplified. I just took a common from the LHS and we got a into 1 by r plus 1 plus r equals 39 by 10. I just named this equation as equation number 1. Then what else is given in the question? their product is 1. So product of these three terms, I have to write it to be equal to 1. Okay, again by data we have what? A by R into AR equals 1. A by R into AR equals 1. Okay. On simplifying this equation, what do we get? R cancels with R, and what do we have? A into A is A cube. A cube equals 1. Taking the cube root, what is value of A? Value of A is 1. We are only considering the real roots of A here and not the complex roots. So value of A is equal to 1. Now we will substitute the value of A being equal to 1 in equation 1 and find out the value of R. Okay. Now put A equals 1 in equation 1. We are putting value of A equals 1 in equation 1. So what do we get? We get value of A is 1 into what are we left with? 1 by R plus 1 plus R equals 39 by 10. So we have substituted value of A to be 1 in equation 1. Now we can simplify this equation to find out value of R. We'll do that. I'll take the LCM as R here. So LCM is R on the LHS. What am I left with? 1 plus R square in the numerator. What are we left on the RHS? 39 by 10. Okay. On cross multiplying this, what do we get? 10 into 1, 10 plus 10 into R, 10R plus 10 into R square, 10R square equals 39 into R. What do we get? 39R. Okay. Now we will take 39R on the LHS. So what do we get? I am taking 39R on the LHS. First I'll write R square term, that is 10R square. 39R when it comes on the LHS becomes minus 39R. 39R plus 10R gives us minus 29R. What am I left with? Plus 10 equals 0. So we have a quadratic equation in R. 10R square minus 29R plus 10 equals 0. Now we will find out the factors for this quadratic equation. So I have to multiply these two. We have 100R square. So what might be the factors? The factors for this will be minus 25R minus 4R. Minus 25R into minus 4R gives us 100R square. When I add both minus 25R plus minus 4R, it gives us minus 29R. So we'll use that. 10R square minus 25R minus 4R plus 10 equals 0. Okay. Then from the first two terms I can take 5R common. From the first two terms I am taking 5R common. What are we left with? I am left with 2R minus 5. Then from the last two terms I can take 2 as the common factor. So I will take plus 2 or minus 2 as the common factor I'll take. Okay. if I take minus 2 as the common factor, what am I left with here? 2r plus 2r minus 5 equals 0. Okay, on simplifying this, what do we get? 2r minus 5 into 5r minus 2 equals 0. So what are the two values of r? So r, we get it to be plus 5 by 2, and value of r here is plus 2 by 5. So we found out two values for r and one value for a. Hence we are going to get two different GPs. We will find that out now. So what were the terms of the GP? The terms of the GP were a by r, a and ar, right? So when value of r is 5 by 2, right, and value of a is 1, what is the GP? The terms of the GP are a by r, value of a is 1, r value is 5 by 2, a by r, comma a value is 1, comma a into r, that is 1 into 5 by 2. So this is nothing but 1 by 5 by 2 is 2 by 5, comma 1, comma 5 by 2. So the GP when r takes the value 5 by 2 is 2 by 5, comma 1, comma 5 by 2. Similarly, the next case, when r takes the value 2 by 5, when r equals 2 by 5 and value of a obviously is equal to 1, the terms of the GP are what? A by r, a value is 1, a by r value is 2 by 5, comma a 1, comma a into r, that is 1 into 2 by 5. So on simplifying, what do we get? 1 by 2 by 5 is 5 by 2, comma 1, comma 2 by 5. So when r takes the value 5 by 2, the terms of the GP are 2 by 5, comma 1, comma 5 by 2. When r takes the value 2 by 5, terms of the GP are 5 by 2, comma 1, comma 2 by 5. Moving on to the next problem. The next problem states that how many terms of the GP 3, 3 square, 3 cube, so on are needed to give the sum 120. So we have to find out the number of terms that are needed of this particular GP to give the sum 120. We will start the solution like this. Okay, the given GP is, what is the given GP? 3, 3 square, 3 cube, so on. Okay, here what is the first term? First term is 3, so I write a equals 3. What is common ratio r? 3 square by 3 gives us 3. So the first term is also 3, common ratio is also equal to 3. Now what else is given? Sum is given to be 120. So we will take Sn to be 120. Sum of n terms of this GP is 120. So we have to find out how many terms of the GP are needed to give the sum 120. So in other words, the question is asking us to find value of small n. Now we will use Sn formula. What is Sn formula? A into r power n minus 1 by r minus 1 equals 120, as it is I have written. So we will substitute values of a and r here. What do we get? A value is 3 into 3 power n minus 1 by 3 minus 1 equals 120. So on further simplifying this, 3 ones are 3 fours are 12, 3 zeros are 0, 40. So what do we get? We get 3 power n minus 1 divided by 3 minus 1 is 2 divided by 2 equals 40. Okay, on cross multiplying this, what do we get? 3 power n minus 1 equals 40 into 2 is 80. Taking minus 1 that side, what do we get? 3 power n equals 81. To find out value of n, I have to write 81 in powers of 3. So 3 to which power is 81? 3 to the power of 4 is 81. So I can write 3 power n equals 3 power 4. So the bases of these two exponents are equal. The exponents themselves are equal. Hence the powers must be same. Hence value of n is 4. So what is the meaning of saying value of n is 4? That is, we need the first 4 terms of this particular GP for us to give the sum 120. Moving on to the next problem. The next problem states that find the sum to n terms of the sequence 8, 88, 888, 8888, so on. So we have a sequence. This is the given sequence 8, 88, 888, 8000, 888 and so on. So we'll start the solution like this. Solution. We need to find 8 plus 88 plus 888 plus 8888 plus so on. So the question is asking us to find the sum to n terms of this particular sequence. That is 8 plus 88 plus 888 plus 8888 plus so on up to n terms. So the sum to n terms is nothing but we have to add the terms of this sequence up to n terms. So basically we need to find 8 plus 88 plus 888 plus so on up to n terms. Now the next step, what we are going to do is, I can write this as, I will take 8 common from each term of this series. Okay, I will take 8 common from each term of this particular series. So what do we get? If I take 8 common from the first term, I am left with 1 here. So I write 8 into 1 plus. Again, we are taking 8 common from the second term, 88. So what are we left here? We are left with 11 plus 8 common from the third term. What are we left with? 111 plus 8 common from the fourth term. What are we left with? 1111 plus so on up to n terms. So what have we done? The first step is we have taken 8 common from this series. Okay, so I am taking 8 common from this series. I am left with 1 plus 11 plus 111 plus 1111 plus so on up to n terms. Then the next step, I am going to multiply and divide by 9. Okay, so multiplying and dividing by 9, we get 8 into 9 by 9 into 1 plus 11 plus 111 plus 1111 plus so on up to n terms. Okay, so I have multiplied and divided by 9. Then I keep this 9 as it is and I multiply this 9 with this particular series. So what do we get? 8 by 9 as it is outside. When I multiply 9 with this series, what do we get? I get 9 plus 99 plus 999 plus 9999 plus so on up to n terms. Okay, so what have we done? The first step, we have taken 8 common, then we have multiplied and divided by 9. Then the third step, 8 by 9 as it is, and I am multiplying 9 with this particular series. So we have got 9 plus 99 plus 999 plus 9999 up to n terms. Now the next step, 8 by 9 as it is, I can write 9 as 10 minus 1, right? This first term 9, I can write it as 10 minus 1 plus 99, I can write it as 100 minus 1. Okay, 9 I have written it as 10 minus 1 plus 99, I can write it as 100 minus 1 plus 999, I can write it as 1000 minus 1. Then 9999, I can write it as 10,000 minus 1. So that is 10,000 minus 1 plus so on up to n terms. Okay, so what have we done? I have written 9 as 10 minus 1, 99 as 100 minus 1, 999 as 1000 minus 1, 9999 as 10,000 minus 1 up to n terms. Then next step, okay, 8 by 9 as it is, 10 minus 1 plus 100 in powers of 10. What is 100 in powers of 10? It is nothing but 10 square minus 1. 100 in powers of 10 is 10 square minus 1. 1000 in powers of 10 is 10 cube. 10 cube minus 1. 10,000 in powers of 10 is 10 power 4 minus 1 plus so on up to n terms. So I have just written 10, 100, 1000, 10,000 in powers of 10. Okay. Now 8 by 9 as it is, I will write the powers of 10 to one side and minus 1 separately. Okay, what do we have? 10 plus 10 square plus 10 cube plus 10 power 4 plus so on up to how many terms? Up to n terms. Up to n terms. What else am I left with? We are left with minus 1, minus 1, minus 1 up to n terms. So I can write plus minus 1 plus minus 1 plus minus 1 plus so on up to n terms. Okay. So what is this step? How did we get this step? I have just separated powers of 10 and minus 1. 10 plus 10 square plus 10 cube plus 10 power 4 plus up to how many terms? N terms, plus I have written minus 1 plus minus 1 plus minus 1 up to n terms. Now next step, 8 by 9 as it is. Look at this series. What kind of a series is this? This is a geometric series with first term 10, common ratio also equal to 10, right? So we have a geometric series, 10 plus 10 square plus 10 cube plus 10 power 4 plus so on, right? It is a geometric series. What is the first term of this geometric series? 10. What is common ratio of this geometric series? That is also equal to 10. So we can write sum to n terms of this geometric series as 10 into 10 power n minus 1 by 10 minus 1. So this follows from SN formula of GP, right? A into R power n minus 1 by R minus 1. Since A is also 10, R is also 10, I have used A into R power n minus 1 by R minus 1 formula. Okay, now look at this, plus what else we have? We have a series where we are adding minus 1 n times, right? So minus 1 I am adding n times. What do I get? I can write that as minus 1 into n, right? So the first series was a geometric series with first term 10, common ratio 10, and the second series was a series where we add minus 1 n times. So I can write that as minus 1 into n. Then we'll simplify this further. 8 by 9 as it is. What am I left with here? 10 into 10 power n minus 1 by 10 minus 1 is nothing but 9. Minus 1 into n is nothing but minus n. So this is the sum to n terms of the sequence 8, 88, 888, 8888, so on. So what did we get? 8 by 9 into 10 power n minus 1 by 9 minus n. So if we have in the place of 8, 88, 888, so on, if suppose you had 7, 77, 777 and so on, same method we need to follow. Okay, first step is taking 7 common, then multiplying and dividing by 9, keeping this 9 as it is, multiplying with this 9, same method, the answer you will get it as 7 by 9 into the same term. Okay, so whatever be the sequence, the same method you follow for this particular problem. So that is it for today's class, students. We'll meet in the next class. Thank you.